Good evening, everyone. So, we welcome you all for the vodQA event, Coimbatore. So, myself, Subhajyoti Rajendran. So, I've been part of Thoughtworks for 2+ years and with an overall experience of 8 years in QA industry. And yeah, so before we move on to the actual talks, right, we'll have a welcome note which will be presented by Sujana Arulselvi. To give an introduction of her, Sujana is a product leader and enterprise architect with 20 years of experience in technology and innovation. She is currently serving as a lead enterprise architect at Thoughtworks. She drives strategic alignment between business, technology, and processes, leading a team of experts dedicated to optimizing organizational agility and decision making. She has also mentored numerous professionals, and her expertise spans product management, customer experience, and enterprise architecture, making her a key driver of technological innovation and strategic growth. So we will hand over the mic to Sujana.
Thank you, Shubha. Good evening, everyone. I would like to formally welcome each and every one of you for the 31st vodQA session. Thank you for taking time to be here. It's been about 4.5 years since I joined this great and amazing organization. During my first week of joining, one of the emails that I received was, you're invited to the vodQA session. And that kept me wondering, why am I invited for a vodQA session? What is this vodQA session about, right? And then I was very pleasantly surprised, to know that this is an amazing and a very brilliant forum, which is specifically focusing on value-oriented discussions for quality analysts. That's what vodQA is for. If it's the first time that as a quality analyst you're here in order to be a part of the session. What better name can it have than vodQA, right? All right. So as technologists, I'm sure we all spend a lot of time in keeping ourselves up to date with what we call as cutting edge technology, right? So the goal of all the community events in Thoughtworks, right, which is our bloodline, right, is very simple, and it is just one. That is to come together and learn something new. And the byproduct for that is we get to network, we build a strong community of technologies, and in this case, a strong community of QA through knowledge sharing. I heard from the team that we have done over 30 sessions already throughout the Thoughtworks India offices. And we're absolutely delighted to have each and every one of you for the 31st session, where we have very timely and two interesting topics lined up for you. The first topic is actually a very need-of-the-hour topic. Considering where the world is now, where the industry is, right? And maybe you're hearing from a lot of your projects and you're hearing based on, what we are calling as the macroeconomic headwinds, right? In terms of why is the market down, right? Why are the opportunities down? One is, theme that is actually evolving is optimization, right? Optimization, resource efficiency, faster feedback cycles, and things like that. And that is why I think we have a very interesting topic. The first one, which is about ephemeral test environments, that will be presented by Arun Balaji from Thoughtworks. The second topic is a no-brainer, considering the AI age that we are in now. It's about approach for QA in the AI age. And that will be done by Jaideep and Sumaya from Thoughtworks. So hope you have a great time learning, sharing, and also networking at vodQA. Thank you, and welcome once again.
Thank you, Sujana, for sharing us a quick introduction on what vodQA is and our today's agenda. So we will move on to our first talk, which will be presented by Arun Balaji. So Arun Balaji has joined Thoughtworks 7 months ago, and he's currently serving as a quality lead and he has an overall of experience with 10 plus years. He had predominantly worked in quality assurance space with a strong emphasis on automating tests and building scalable, sustainable test automation solutions. And he has also worked across various industries, including healthcare, communications, and financial services. So the interesting thing about him is he likes to play cricket and table tennis, and he's also an active gym goer. So over to you, Arun.
Check, check. Hey, hello everyone. So thank you for the modest interview. At least my cricket is getting recognized here. So the intention for this is to basically open up this conversation about ephemeral test environment. All right, yeah, it's cool. Okay, so to open up this talk about ephemeral test environment and to basically open up this conversation and to hear from you on what is your thoughts, and basically it's going to be a discussion, more of an interaction. I'll share my knowledge and based on my experience, what I've gone through for setting up an ephemeral test environment. So I would like to hear from you on what is your experience, and we'll take that forward. So let's look at the agenda for today. So we'll set the stage with discussing about the test environment conundrum. What I mean by this is there are a few options for us to basically consider while setting up a test environment, right? So like static environments, staging environments, and then the ephemeral. So what would fit what, right? So that's the conundrum that we have, and basically we are going to extend on this and discuss further. And why ephemeral? What is the essence? What is the word? What does the word mean? And then let's look at the essence and what is the need. And as she was saying, it's more of a need of an hour these days. So what is the need for it? And we'll discuss about the life cycle of an ephemeral environment. So starting with provisioning and then to deploying an application and then executing tests and all the way down to tear down. So we'll look at the life cycle and the anatomy of a robust ephemeral setup. What I mean by anatomy is basically like looking at the tools that are available. Let's strip down the tools that are available in the market for an ephemeral setup and see which tool will apply for what, right? Like for example, Docker Compose, etc. So we cannot be using all the tools at once. So we'll look at which tool would apply for what and basically have some conversation around it. And then we'll discuss about the pain points, some of the trade-offs we have to go through, what are the mitigations for those pain points, and we'll close this talk with a small demo and open up for question and answers. So with that considered, so this is what we are going to learn today. So we'll move on to looking at the hurdle, which is the shared static test environment. So this, you would have faced a lot of times where a lot of users are trying to basically use a shared static environment, as you can see on the left. There are few users who are trying to use a staging environment. And if, let's say, some of the users, or let's say if Amita is trying to introduce a change, which basically breaks the staging environment, the others has to wait, and they are basically competing for resources, right? So in a testing space, what it all requires is an application to be in a good shape for us to test, right? So if you're competing for resources for you to go through your tests, that is a big pain point, right? And that is why we have to consider something ephemeral. And the configuration chaos, right? So let's say if John is trying to introduce a configuration, and let's say if Alice is not comfortable with that configuration, and she feels that it's not mimicking production environment, so she has to wait for John to basically revert back and then introduce a change. So this chaos always happens with a shared space, especially in an environment perspective in the context of quality assurance. And flakiness. So when it comes to flakiness that is related to test environment, predominantly it's because of the residual data that we leave after we run the test, right? So we basically bring in data, seed data to an environment, we run tests, and we basically leave that right there, right? So basically, like if someone else wants to run their tests, they would not have the application in a state where it would not be flaky, right? So that's a big pain point for in this horizon. And reduce test autonomy. What I mean by this is if Jason wants to, let's say, exercise some new code to his automation code, and basically if William is not comfortable with that code and basically he wants to revert, you do not have a way to basically do this in a shared static environment because you do not have a lot of autonomy to exercise your own stuff, right? So that's another big pain point that we have. So now that we understood what is the hurdle, let's look at the solution for this, which is ephemeral, right? So what do we mean by ephemeral? The word, the synonym is basically something temporary, right? So anything that is on demand, temporary, that are spun up only for testing purposes is what we call the ephemeral test environment, right? So as you can see in this diagram, so basically like the costs of a shared static environment will exponentially increase for the entire tenure it is going to run. Whereas the cost of an ephemeral environment will be only billed, you will be only billed for what you use, right? So in that context, the cost effectiveness is exponential in the longer run, right? So that's one key advantage. And the other thing is how instant you can provision these environments, right? So let's say you have a set of containers and you have a Docker compose that for your system. It's quite easy to provision this versus a shared static environment that requires a lot of sophistication and a lot of configuration to provision. So that's another big advantage. And customizable configurations for mimicking production. So going back to my example of Docker Compose, right? So if you have like 20 or 25 components running on your Docker Compose, and if you want to mimic production, you would ideally want to take one version of one component and map it against another version of another component in a Docker Compose setup. So this is quite, I would say, it's quite flexible to exercise these kind of configurations in a ephemeral space versus a shared static space where it's going to be a little more challenging, right? So with that remedy mentioned, let's look at the life cycle of an ephemeral environment. What does it go through? What is a tester's job in basically identifying what it goes through, and generally what does it go through, right? So it starts from the far left where we are provisioning the infrastructure. So the infrastructure can be provisioned in two ways. One is to use some sort of, you can just log into your own cloud provider and provision the infrastructure like AWS, Azure, etc. Or you can choose to do this through something called as IAC, which is infrastructure as code, right? So you can use tools like Terraform, CloudFormation, Ansible, etc. to do this. And if you choose to do this manually, it's fine, but there are some disadvantages that we will see in the later times. And the configuration and installation, like, generally when you configure for an ephemeral space, you can basically install using an IAC, like Docker, Docker Compose, etc. Or you can choose to do this manually as well. And seeding data. So seeding data is quite essential because it's almost implicit that in a shared static space where you have the application deployed all the time, there will be data for you to test. Whereas in an ephemeral space, it's not the case because you are spinning up the infrastructure on your own and you are bringing up the application, right? You're basically doing a Docker Compose up and bringing up the application, right? So in those cases, data, it's not safe to assume that the data will be there for you to test, right? So that is why seeding data is quite essential in this space. And pre-test validations. What I mean by this is, as I was saying, it's almost implicit that in a staging environment, you will have your applications deployed. You will have all the necessary data that is pre-configured in your application. But in an ephemeral space, this is not the case, right? So you would want to have some sort of sanity checks for your environment to make sure that your tests are in a very good state to execute, right? So pre-test validations are like more like a 101 for this space. And as far as test execution is concerned, can you hear me loud and clear? Cool. As far as test execution is concerned, one thing that you can exercise with ephemeral environment is dynamic scaling, right? So generally when we go for parallel test executions and everything, we would have gone through some issues where it failed because the resources was not available, right? We would have let's say, even in browser testing using Selenium, if we just bring up like, 6 to 7 browsers, and it takes a toll on the RAM, and it fails basically due to unavailability of space, RAM capacity, etc. Right, and that is why dynamic scaling is quite essential in this context. And for this, you can use tools like Kubernetes or any orchestrator for you to surface this, and you can use parallel test execution here. And the other part where I marked it in a dotted line is because it's optional. Because mocking and virtualization, it totally depends on how much you want to mimic production. Because if you are mocking a lot, right? If you have a component and if you're mocking everything around it, it takes a hit on your reliability of tests. But at the same time, you cannot load a very heavy application into an ephemeral space, because that will basically make the ephemeral space to go wrong, and basically it will eventually fail due to lack of resources, right? So that is why mocking just enough is essential, but how much we have to basically decide on the level of mocking that we require for tests, right? So that's another caveat that we need to consider. And as far as tear down is concerned, on the far right, we'll start with archiving logs. We'll move on to archiving reports. Then we decommission, and then we do the cleanup. So why archiving logs is important is because eventually you will not have the environment up and running, right? So eventually you will have the tests executed. You will have the reports. You will have the logs, but you will not have a way to basically log into that environment to see what went wrong if your tests are failing, right? So that is why archiving logs is quite essential in this space. And so is the case with reports, decommissioning and cleanup, etc. So with this life cycle in mind, let's look at what it takes to set up a robust ephemeral setup, right? So let's look at the anatomy. What I mean by anatomy again is like, let's strip down what are the things and what are the tools that you can use to basically set this up. So we'll start with containerization first. So containerization is more like a 101 again, because eventually you will need this to exercise flexibility. What I mean by this is, if you'd like to configure your compose in a Docker compose in a way that you can mimic your production environment, you would need a Docker compose setup, and you would need a containerization in place, right? So that is why this is more like a 101 for you. And you can use tools like Docker, and if you'd like to have auto scaling and orchestration, you can use Kubernetes and Docker compose, of course. And dependency mocking, as I was saying, we have to mock just enough. Like, you cannot mock everything because it eventually takes a hit on your reliability of tests. And at the same time, you cannot load a very heavy application in an ephemeral space, right? So if your application has, let's say, 16 or 17 components and all of them are microservices, and if you'd like to exercise that in an ephemeral space, it is going to take a hit down the line on how much capacity you would need for an ephemeral space, and it would basically make sure that you're failing. You're setting up for failure if you just load all the components at once, right? And that is why you need some sort of mocking in place. You can use Mockito, JMock, or YMock. You would have come across all this. But one thing which you consider is striking a balance between not mocking too much and mocking just enough, right? So we have to strike a balance between them. And infrastructure as code. As I was saying, this is an optional step, but this is a very useful step, because at the end of the day, if you would want to have a blueprint that is proven to work for others, right? Like, if you are setting up, if you are provisioning for an ephemeral space, if you're logging into, let's say, an AWS and trying to set up some EC2 instances, you would want to do this through IAC, like Terraform, Ansible, etc., because that gives a blueprint for rest of them to follow, right? So you are basically a front runner if you do that. So that is quite essential. And CI/CD integration for tests. So let's say the most useful use case for an ephemeral space, in my opinion, is sanity test, right? So let's say if you have a CI/CD pipeline, you have a build pipeline where a developer is trying to build a Docker image, and if he has to basically test, he has to wait all the way towards the right? What I mean by towards the right is towards the right in the software development lifecycle, right? So he has to basically run some functional tests and see if the image is going through and if the image is, tested enough for it to move to the artifactory, right? So in those cases, we can consider a pipeline where it basically spins up the environment, runs the tests, and then basically tears down on a developer image. Like if there is a developer Docker image, and if we can exercise this in a very short span of time, it basically means that you're shifting left on your testing efforts, right? So that is why the CI/CD integration is important, and you can basically provide faster feedback, and all the nuances and experiences with shift left, you can get it through CI/CD pipeline using an ephemeral environment in a sanity test, right? So that is why this is also a more like a 101, and we require this to basically be successful in an ephemeral space. So if there are no questions, I will move on to discussing the pain points. So the setup complexity, right? So first of all, this is not a fit for all solution. So this would not apply for everything, and this will not apply for all states of your project, right? Like if you're building an application from scratch, it would definitely apply, because if you are using Docker Compose, etc., it's more like a plug and play, right? You can take the infrastructure as code template. You can create, provision the infrastructure. There would be templates that exist for CI/CD pipelines as well. So you can take them and you can basically construct a ephemeral space here. But if there is an application that has a lot of tightly coupled stuff with its own database, with its own components, etc., this is definitely not plug and play. And that is why you need to be very conscious about what is the return of investment you are putting when it comes to setting up an ephemeral environment. And limited debugging. So what I mean by this is, ideally, if you would like to run your tests, and if the tests fail, you would like to log into that environment to see what has gone wrong, right? So in a Docker environment, you would basically log into a Docker container to see the logs, to understand what has gone wrong, right? But this cannot happen in an ephemeral space because the Docker containers would not exist. You cannot log into the EC2 instance because the EC2 instance is stopped. In my case, in my demo, it is an EC2 instance, but it could be any cloud provider, right? So basically, you have to take a punt on your test reports to rely and decide whether your tests are passing for the right reasons or failing for the right reasons, right? So that is why debugging is a pain point, but how you can mitigate this is you can basically transform or translate all the logs into into some sort of storage system, let's say S3, right? So that way you can basically log into S3 afterwards and basically see what has gone wrong, right? After, if your tests are failing. So that in that sense, it is a pain point, but that is a very simple workaround for this, to be honest. And resource leaks. What I mean by this is, let's say you have set up an ephemeral environment and you are running your tests, and due to a test failure, let's say the pipeline is exiting out. What it basically means is that your system is not ephemeral. It will still be executing, it will still be running, and you will be costed for how long ever it runs, right? So in those cases, it is very crucial to understand that it's more like a mandatory thing to do in an ephemeral space, because even if your tests fail, you have to basically make sure that your instances and the EC2 instances and all the infrastructure that you're using for tests is stopped. Otherwise, it's going to cause a lot of leaks, and that is going to add up exponentially on your costs eventually. So integration challenges, as I was saying, if there is communication, there would be a lot of integration challenges for a legacy application which has been there for quite a long time, and predominantly if there is multiple touch points, right? Like if your application is depending on a database for bringing in data, of course it will be looking out for there will be consumers for your application if your application is a provider, and if you are a consumer, there will be a lot of providers for your application. So in those cases, the communication can break, right? It is prone to break in an ephemeral space. So you have to basically carefully set up And at the same time, there will be challenges through this. And that is why you go for some sort of blueprint using Terraform or CloudFormation, etc. So that is one mitigation for this. But this is a pain point, and we have to basically address that. So with the pain points in mind, let's look at the risk register for an ephemeral space. Let's start from bottom up because most of them are high likelihood in the bottom. And the first one is dependency availability. So this is a huge risk because and the likelihood of this is high. And that is why we need mocking, because you cannot basically trust a third party service to provide you the right information all the time, right? So in those cases, it could be databases, APIs, third party APIs, etc. And in those cases, it's advised to basically mock out those dependencies, provide some service virtualization, and basically isolate your component from those dependencies to run some isolated tests. So that's the mitigation for it. And test failures due to under provisioning. So we oftentimes kind of what you call it? We underestimate our tests, right? So we write some tests, we do some dry runs, monitor for the usage, and we provision an environment for that. But eventually, what we do is we add more tests, we add some parallelism, we add a lot of sophistication for it to basically consume a lot more resources than it would consume initially, right? So in those cases, if you are considering a very small sample size for provisioning a resource, again, you're setting up for failure. And that is why under provisioning is a big risk, right? And you can use, so the mitigation for this is basically like, there should be a mechanism to monitor how much resource your test is using all the time, right? Like for example, CloudWatch combined with Kubernetes, of course, for scaling. But the whole essence of it is that you should have a monitoring system in your ephemeral space to understand how much resource your tests are consuming against the ephemeral space that you have configured, right? So that's again a big risk, and that's the mitigation for it. And at the same time, the other thing about provisioning is that you should be over provisioning. You shouldn't be over provisioning as well. You cannot be very conservative. And if your tests are consuming this amount of data, you cannot exponentially add data so that you're very safe, right? Again, it would defeat the purpose of an ephemeral space, which is saving costs, right? So you cannot over provision the resources as well. So you have to be very mindful of that. And ephemeral loss of logs. So the other nuance with loss of logs is that, of course, as I was saying, you cannot log into the container to see what went wrong if your tests are failing, right? So what you would want to do is you will push it to S3. So that's one part of it. The other part of it is that we would look at logs from today, maybe last week or maximum last month. But you have to be, my point is that you have to basically look for a storage class which is not cost consuming, right? You would not need a Glacier kind of storage where you will look for the logs one year from, last year's logs, etc., right? So you have to be very choosy about the storage that you're using, because you would only want the logs where your tests are failing, one. And the other thing is, like, you would not want logs that are 1 year earlier or 2 years earlier, right? So you have to basically choose a storage class accordingly. And data management complexities. So what I mean by this is, you will be using your data for tests, and someone else will be using some other data for tests. Especially while seeding data, we choose to be conservative and seed data that will that might have synchronization issues with other users, right? And that is why we have to use some sort of seeding mechanism. And while using the seeding mechanism, we have to use a representative subset of data. What I mean by this is, you cannot, again, it goes back to my previous notion where I mentioned you cannot use a very heavy application in an ephemeral space. So similarly, you cannot load a very big data. You cannot load big data into an ephemeral space. You have to basically choose a comprehensive but representative subset for you to use, right? So that's another nuance that you have to consider, and that's the mitigation for it. Of course, you can version your data sets and use, but more viable option is like to use a representative subset of your data that is comprehensive enough to not take a hit on the reliability of tests, right? So with the risk that we just mentioned, I will move on to showing the demo. It's a very short demo of a basic application and how was my journey to set up an ephemeral environment for tests. So as far as provisioning is concerned, anything that you see with a human icon is basically manual, and anything that you see with a play button is automated. And blue stickies are on-prem, and yellow stickies are cloud. So for provisioning, basically you have to design the app. This is for when you are building an app from scratch. You have to basically design the app and add the tests, and you will configure. You will just bundle this app into a Docker file, and then you will add Docker Compose for configurations for plugging in all the dependencies for your app, and you will provision the resource in your cloud. Again, I mean, you can choose your own cloud provider, and you'll basically log in and provision the resources, or use tools like Terraform to basically provision on its own, create a template and provision on its own. And then the CI/CD configurations using Jenkins for you to basically plug this piece into your software development lifecycle. So it gives you some ephemeral advantages. So as far as execution is concerned, most of them is automated, as you can see. We trigger the pre-configured infrastructure. We deploy the Docker containers for the application. We execute tests on the infrastructure, and then we perform the teardown and cleanup. Everything is automated. So it's more of a one-time setup that you need to do. And once you have the CI/CD configurations in place, and once you're plugged into your pipeline, most of them is automated, right? So yeah, so with that considered, I will move on to showing my journey of setting up an ephemeral test. So as you can see here, I have an application, a basic library app, which is responsible for adding books, getting books, deleting books, etc. And I've added a few tests on top of this. These are basic rest assured tests. Application is running on port 8103, and I've added a few tests on top of this. And there is a Docker file, which is responsible for basic Docker file, which is responsible for bundling the app and basically introducing an entry point through the jar. And there is a Docker Compose, which basically integrates this. Yeah, sure. Visible? Is it visible? Okay. So yeah, so a Docker Compose, which basically integrates this Docker image to a database for you to basically make sure that you have everything for your tests. And there is a mechanism for seeding data in Spring, which I've done it through data.sql, as you can see here. So let's look at the shell script. So I'm doing this through shell script, but you can of course do this through CloudFormation and a lot of other tools like Ansible, Terraform, etc. to do this. But I am doing this through shell script to basically for all of us to understand what is really happening, right? So this shell is basically only responsible for starting the Docker containers. And then I've added some weights, and then it runs the JUnit test and it performs the teardown. So that's all it does. But the main shell script is this one, which is responsible for the whole ephemeral thing, right? Like, bringing up the environment, bringing up the Docker containers for your environment, running the tests, and starting the EC2 instance, running the tests, and basically doing the teardown as well, right? So that's all it covers. So if I am checking if the necessary installations are done, I'm getting some variables like PEM, etc. And then I'm getting the public, I'm starting the EC2 instance first, and I'm getting the public IP of the EC2 instance. And I'm doing an SSH into the EC2 instance, as you can see here. And I'm stopping the EC2 instance and coming out. So that's all I'm doing. So let's basically run this and see what is going through, what it is going through. So I'm defining these two instances in my AWS CLI. As you can see, both of these instances are stopped. We are going to use this instance, which which closes in with 3B4. So let's trigger the script and see what it really does. So it is starting the EC2 instance, as you can see. It is waiting for the instance to be running. So if I define the instances again, now the instance has gone to a running state. So I've applied enough weights for me to basically validate if the installations are done. Yeah. So it is waiting for the instance to be ready, and the wait is basically for verifying if the installations are done and everything is proper for us to proceed with our tests. Yeah, it is asking for my fingerprint. Yeah, now it is starting the environment, as you can see. It is starting all the containers that are required for our application to be executing. And it is checking if the service is up on port 8103. I've added some polling mechanism to see if the service is up. Now it has found the service up and ready in 8103, and it is running the JUnit test. It is running the rest assured test. So let's wait for the test to complete. Yeah, the tests are complete. The build is successful. Now it is stopping the environment, and it is basically removing all the containers, as you can see here. Yeah, so it has removed most of the containers. So let's go back to defining the instances. Yeah, it has gone to a stopping state, and eventually it will be stopped, right? So basically, during the time that I executed the test is when the time the instance was up, right? And the application was up. So this way, you'll be saving a lot in your costs, because only when the pipeline triggers, you will be billed for it, right? Otherwise, you will not be billed for it. And all the benefits that I mentioned, right? Like how easy it is to configure and how easy, I mean, I purposefully did this demo in a very simple fashion for us to easily understand how easy it is to plug and play. So, now it is stopping, and it will eventually be stopped. So you have exited out all the dependencies, and you have you'll also not be billed for this instance from now on, right? So that's all I had for this presentation. But I will open this forum for questions now. So if there is anything that you would like to ask, please feel free to ask. Yeah, please go ahead. Yeah, so seeding, I did it through a Spring Boot application. I mean, it's a Spring Boot application that I executed, right? So seeding, we can do it through Spring Boot. I have a SQL file, and I have a few configurations for it in my properties file, and I'm seeding through it. But, if you want to do this through, I mean, you can do this anyway, right? There is a lot of options, but I did it through a Spring Boot application. So that's pretty much it.
So how are we approaching that data file matrix on that YAML configurations? Since you said that container, no? So when you triggered that, it is populating, then running, then removing. So how are we handling that data file over there?
Oh, what do you mean by data file?
Yeah. So if the rest assured means it needs some data, no? So
Yeah, that
validating. Yeah.
Yeah, so basically when the application is spun up, right? And if you have the data.sql in place that I showed, so it basically makes sure that it's basically a few queries that the data.sql has. Basically a create query, and then the insert query, and basically a commit to make sure that the data is preloaded. And that's all it is, right? A Spring Boot application, and the Spring comes in with this feature. There is a lot of other development forums where it has this feature, and that's pretty much it, right? So that is why I chose with Spring Boot, because eventually you will need this data for your tests, right? And it is basically a simple set of queries that you would need. That's it. Yeah, you can choose to load this through your own APIs as well. You can just, I mean, as Balaji was saying, you can just have this in a CSV file and also load that. So that wouldn't be a big pain, in my opinion. Yeah.
Thank you.
Cool. Yeah, so anybody who has basically implemented from scratch. Yeah, so that's the biggest advantage, as Balaji was saying. So everything is instant, right? Like you have a mechanism to bring this up instant, and it's also autonomous. What I mean by autonomous is like you need not rely on someone else's data if you choose a representative subset of data to load into your test cases, right? So you need not rely on someone else's data, and you basically have the freedom to exercise your own stuff. It's more like a playground where you can just load any data and run any tests, right? So any test that would mimic a production environment. So with that, after wearing that lens, if you approach this that way, it would be really beneficial. Yeah. Anything else? Right. So I think we are towards the closure. So, but if you'd like to reach out to me personally, I mean, I'm happy to collaborate with you, to learn from you and also share my experiences. So please feel free to touch base. Yeah. Thank you so much, folks.